Today I'm going to introduce the code of my AI4EO project. First of all, the dataset I'm using covers the 10 types of the data shown above. The first part of the code shows the basic information of the dataset. We can see that some category have 3,000 images, some have 2,500, and some only have 2,000. In total, there are 27,000 images of 64 times 64 pixel size image we have. The second part of the code builds and trains the ANN model. Because the amount of the data in the dataset was too large, I first chose only 10% of the data to use for time cost reason, where 2% of the data was using for testing and 8% for training. Also, for comparing with other models, I use the random state to set the random seed to make sure that the training set and the test set are the same every time. Also, with setting up the training set and data set, I use image data generator to random transform the image to increase the diversity of the training data. After that, I built and complied the ANN model and trained the model and finally draw the image and of the loss and accuracy. Through the image, we can see that this model is completely unusable. That's because the AI model can be understood as pulling the pixel of the image into a straight line. It has no way to understand what the photo actually means. The third part of the code builds the CNN model, which is based on AN and then performed convolution and pooling operations so that the spatial information and the local correlation of the image can be accurately identified. In the code, we also divide the dataset and training set first, and then construct and train the model to draw the image of loss and accuracy. This time we can see that the accuracy is increasing with the number of epochs, while loss is decreasing with the number of epochs, indicating that our model is successful. It's worth noting that between 40 and 50 epochs, the test accuracy is a bit lower than the trained accuracy, which could be indicate that the model is overfitting a bit, but not by a lot. So we cannot completely sure about this, but it should be paid more attention to in future training. After that, I draw the confusion matrix, in which we can see which categories are recognized actually and which are often confused with other categories. We can see that the forest can be recognized easily, but there are some sea lakes that only recognized as forest, probably because they are all dark and large color blocks, and the highway is always recognized as river, probably because they look thin and long. Finally, I choose some random samples to check if their predictions are the same as the real labels, which give us a more visual appealing view of how the model works. We can see that the highway is recognized as river, the two crops are confused, and the parent crops is recognized as a residential. Honestly, I think it looks like house too. In the end, I construct the vision transfer model, which is again different from CNN in that it divides the image into fixed size patches and classifies the image by computing the positional relationship of the part of the image through the model. The previous steps are still really the same. Both classify the dataset and then build and train the model. In terms of the results produced, we can see the version transfers accuracy and loss also get better with increasing epochs, and the final result is also better than the CNN. However, vision transform does not perform as well as the CNN in terms of loss in beginning, which shows that it requires more training data compared to CNN. The result of confusion matrix are interesting. First of all residential are recognized correctly, and the mistake made by CNN on Helix are solved, but the problem of highway is still there. In the final sample prediction image, luckily there were no error, but it's also proved that vision transfer is better than CNN. Overall, for my project, I compared the results of the three different models, ANN, CNN, and version transfer, and came up with version transfer having the best performance. Through the computational volume and the training data required were also the largest. This project also used deep learning to classify land cover and land use, so anyone can use this project to classify image and observe the results for Earth observation.